this. 0, 1, 1, 0, 3, 4, right? About reasonable for input. And it's good. It's not important for this brute force thing. So let's say we have this and we passed in. What we're actually trying to do is we're making every single possible combination, right? That's 1, 0, 3, 1, 0, 4, 1, 3, 4, 0, 3, 4. Did I miss anything? I feel like I missed something. Close enough, right? My point being, you're going and finding all possible pairs. And that's what? N to the 3? N to the 3? Yeah. And that will take forever. But it works because now you can go through all of these pairs, add those numbers up, and if they don't equal whatever, 0, if they don't equal 0, then you cross off the list. And now you have your correct answers. But that took forever. But it works. So first of all, let's say that. So you say that during fear, this is a naive situation, solution, but it works. So now, let's figure out how to make this better. Using data structures or using techniques that I listed up here, or anything else, yes?
So once you have your A and B,
yes.
To make that number equal to 0, there would only be one option for C, right? So say in your
yes.
example, if I had a 1 and a 0, right?
Mm-hmm.
I know that only a -1 for C could make that equal to 0. So because I know what I'm looking for, we could use a direct access method like a hash map, right? To like in O1 time, find that -1, see if it exists, and if it exists, make it into a tuple. You know?
Right. Did everyone get that, or should I draw that more?
Draw it.
Draw it? Okay. Try and draw it quickly. Am I still on the camera?
Yes.
Okay, thanks. I just want to make sure I'm not writing like on the side of the camera. So let's do a for loop through that list. 0, 1, 0, 3, 4. Right? And then you do a for loop through these, and you get the first one. And then you do for loop through the second, and you get the second. And now you have two numbers. Let's say 1 and 3. Right? So you have two numbers. And now you need to find out if there's anything that equals 0. So maybe you know that 1 plus 3 equals 4. Great, which means that the remaining number has to be 4. Which means these two numbers will satisfy something if it's a -4. Right? If the last number is a -4, if there's a -4 somewhere in the list, that'll work. Right? What's up?
As long as you haven't already used the -4.
True. As long as I haven't already used the -4. I'll come back to that later because I have a solution, but an ugly one, not a good one that I use. So because you want to look for the -4, what he was suggesting was instead of looking through the entire array again, just a waste of time, you hash these. So you go, I do not know how to draw a hash map. That's your hash map, just random access memory, but you go, okay, is 1 here? Or sorry, is -4 there? And no, -4 is not there, right? Does that make sense? Or -4 is there and this is a pair, right? Is that about intuitive? Okay, now for the problem of repeated numbers, how do we do that? Let's say 2 and -4. That sound about right? Let's say we have 2 and -4 here, and we're looking for a 2 to round out our triplet, right? What I could theoretically do is, because I can build a hash map of any type. So I could theoretically build some hash map of like, this thing holds a number, right? So I know when I put it in, there's 1, 0, there's 1, 1, there's 1, 3, 1, 4. Or let's say there's another 4 and I can say there's 2 here. And then I subtract that from here. But already you're getting confused, right? So although this is great, it doesn't fix everything. Yes? Okay. So that is one solution you can acknowledge. You can say, I want to use a hash map to access the last 0 member of the list, or whatever you want to call it. Any other solutions? Any other thoughts? Yes?
You could do a similar thing about knowing when you've gone too far.
if you sort the original list,
Yes.
and then you go from, say for the third number, if you know it has to be -4, you go from the lowest number to the highest number as soon as you pass the position where -4 should be, or as soon as you hit a number that's higher than -4, you can stop because you know there's no answer.
Yes. So, sorting. We mentioned sorting before. It's really useful when you're using arrays lists and you need to do some lookups or comparisons. So, no one say anything yet. What is the runtime of the optimal sort, of the fastest sort?
Login.
Login. Everyone get that?
No one say anything.
Everyone understand login? Yes, login time. Merge sort, quick sort, about give you login time. So just understand that that's the fastest that you can sort. So if you use that tool, it'll give you login time. Okay, let's take that array.
It's n login, sorry.
And login, sorry, my bad, yes.
Unless you
Wishful thinking. Maybe in the quantum realm. Okay, so we have this array, right? Let's sort it. 0, 1, 1, 3, 4. And that took us n log n time, right? Okay, so what do? Someone tell me? Yes? What should we do? Okay, so we have this array, right? We're going to find pairs. And then we need that third number. Because now we have things that are easier to look up faster. So let's say you did a binary search. How fast is binary search?
Login.
Login, yes. So binary search, ooh, that's nice, is login. Remember that. You need to remember these two because they're important. You can't go in and go, I want to use a sort. How long is it going to take? I don't know. You better know. You better know how fast it's going to take. Because maybe you can find a better solution. Binary search is going to take log n time. So let's say you have the first number and the second number, and you want to find whether or not the third number is in that list. You can do binary search. But I think your solution was slightly different, right? It's faster. This is not the greatest. I forgot most of
Well,
it.
my answer was just like once you find the first two, then the third one is you can stop. But I'm sure there's a way to figure out the first two earlier on.
Yes. You're right. Any thoughts?
What if you use like a modified version of divide and conquer?
How so? How would it?
So for example, you divide the problem into like two subsets, and then you try to, firstly you can find solution within those two subsets, and then you can combine these two subsets and then find a solution with that combines, like has numbers within those two subsets.
With
So-
3 numbers, that sounds tough to me. With 4 numbers, maybe. But I'm not sure about.
So you can have, for example, the pairs that are negative on one side. You can find the positive value of that on the other subset. Then you can merge these two as a solution, and
Okay.
then have the same thing on the other side. And then, like this way, you can combine two subsets
Okay.
together. And then if you have it sorted, then yeah.
That's actually good because if you know like where 0 is,
Yes.
then that reduces the problem. You know that there's 2 on one side and 1 on the other side, except for the special case where 0 is included.
Yes. Yes.
But what if there's no 0?
Well, then you don't have to worry about the special case, and you just go on to his solution. 0 is the worst case.
Or what if it's all positive numbers, or what if it's all negative numbers, or what if
But
it's
then you have
There's no
solution.
solution.
You can tell really
Yeah.
quick that there's no solution.
Because if you do that situation where there's only positives and no zeros, you immediately say, okay, no zeros, so no special case, and no negative numbers, so there's no solution, and you're done.
And I think it's probably it's in login.
Log in. Probably.
Well, and logging, you have to sort it first.
Okay.
Yeah, like after sorting.
So you still have to choose two from one side. And
We'll talk about the specifics, or you guys can talk about the specifics later. What matters is that there are different ways of breaking up the solution. When you go into higher programming, you can learn dynamic programming, divide and conquer, all these different methods in order to look at a problem differently and recurse down or break it up in different ways, or reuse solutions. We won't worry about that too much. Thank you though, much appreciated. But yes, there are probably slightly faster ways, but n squared is,
How about backtracking?
backtracking?
Yeah.
Oh God, I wouldn't even want to think about that. Let's say this is like a 30-minute question, right? You might not have time for that. So because we don't have that much time for this example, I want to get you guys working on your own. I'm going to pretend, I think the n squared one is fast enough. Let's say that was the fastest one we came up with, and I could not easily come up with a simple, faster solution right now. Right? So let's assume that was fast. Okay. So I have that algorithm. How fast is it? Approximately. N squared. Yep. And then O1 lookup with the hash map. And then NON to put things into the hash map. Let's assume that janky thing worked. Right? Because again, we're running out of time and I don't want to write a huge page of code. So now you know your thing works. You've tested it a couple times with a couple inputs. Then we code. Right? I don't think you guys need me to show you the code. Do you? No? Okay. We'll skip that then. But at this point, this is when you code it. You write out all the code, you take your time, you say what you're doing out loud, and then you run through it with examples one more time. Because when you're seeing that algorithm, it's different from thinking it. You might miss something, or you might understand there's a better solution. Right? And once you've done that, you have a solution that is correct, mostly, that is fast, and doesn't take much space. Okay? Okay, so what we're going to do now is we're going to break off into a couple of groups, Panir. We're going to split you guys off. You're going to work on different problems. Again, if you really prefer working on those hard LeetCode problems in the back with the headphones on, go right ahead. But we encourage you to work with other people, learn these interview techniques, learn how to communicate. Because a problem and a solution is useless if you can't communicate it to the people who matter. If you have any questions, we'll be here to help you guys. But the problem shouldn't be too hard. Spend your time thinking about them and what's the fastest way or best way to do it.
Yeah.
Any questions? Okay. Thanks, guys. I passed off to Premier.
Yeah, so instead of me giving you problems, I think you can just go like